session. Okay. So, reactions of alkenes. First of all, I would like to describe that why alkenes are more reactive as compared to alkanes. First of all, we know that alkanes, they have a sigma bond which is present among them, sigma bond present. And this sigma bond, it is harder to break because it needs a lot of energy, so it's harder to break. While on the other hand, we have alkenes. One more thing, alkenes, they are basically called as saturated hydrocarbons because of single bond, saturated hydrocarbons. On the other hand, alkenes are called as unsaturated hydrocarbons. So they are reactive because of presence of double bond. Double bond. Like, how can we describe this thing? Like, for example, we have the molecule of ethene. This is ethene. The first bond that is present here, that is basically sigma bond. And this bond, that is basically pi bond. Now, why pi bond is more reactive? The reason behind is that let's consider the structure of this ethene. Like if we draw its structure, like this is this kind of structure it would be having. So they are basically sharing this sigma bond here. This is basically sigma bond here. And now there is a pi bond here. How this pi bond is formed? This is basically a pi bond. And you can see the electrons, they are basically distributed at this place. They can be at this place, they can be at this place, they can be at this place.
So
Even
is
at,
it polar?
yes, it's polar
Okay.
as well. And you can see the electron density is distributed at this place. Electrons can be at this place, can be at this place, can be at this place. So this thing makes this alkene, you can say more reactive because of greater availability of electron, because of greater availability of electrons. Is that clear, Sultan?
Yes.
Because you can see that in sigma bonds, electrons are just present at this place, at this place. Electrons are present at this place for sigma bond. But for a pi bond, electron density is distributed at this region. So that makes alkenes even more reactive. Okay. So this kind
Okay.
of question, like I'll discuss that question later. And now I just want to move towards the term that I want to explain you about electrophile. In the second term, I want to describe you about nucleophile. So electrophile is basically an electron deficient species. Deficient species. Deficient means the one which is having less amount of electrons. Like for example, we would be having H positive. This is basically electron deficient species. Why? Because this hydrogen has only one electron which has already been lost here. Okay. And you can see, like, for example, if we have this HCl, and we know that it is having partial positive charge, partial negative charge. So when they are going to break, they are going to break like this, H positive, and Cl is going to break like this, okay, with a negative charge. So beta, this one is basically called as electrophile, and this Cl is basically named to be as nucleophile. Is that clear?
Yes.
One more important thing, nucleophile, there are basically three conditions which we can use to represent nucleophile. First of all, they are electron-rich species. Okay, so first example, you can say that an atom or a molecule which is having a lone pair of electrons. Like for example, if you see ammonia, in ammonia, nitrogen has one lone pair present on it. And in water, we have oxygen, which has two lone pair present on it. So they basically represent a nucleophile species. And negatively charged, yani you mean some negative charged electrons, negative charge, you can say atom or polyatomic ion. Like for example, we have OH negative, which has this lone pair present on it. We have Cl negative, which have this pair of electron which is present on it. So they basically represents nucleophile species. And the third one can be alkenes. Okay, alkenes, they also represent a nucleophile species in which you can say atoms would be having a double bond. So these three kind of things, they basically represent a nucleophile species. They represent a nucleophile species. Is that clear, Sultan?
Yeah.
Okay, so let's move ahead. So addition reactions in alkenes. First of all, let's discuss about addition reactions in alkenes. This is ethene. Okay, this kind of question can also be asked that what is bond angle in this alkene? So you must know it that this is S, this is Sp, and this is Sp2. This is Sp2 hybridized, and we know for Sp2 hybridized, the bond angle is, how much is the bond angle for Sp2 hybridization? Do you remember it?
Is it? I don't know what is this SP and SP2 hybridization.
Okay, I'll tell you later in this in the covalent bond chapter. But here you just need to know this sp2 hybridization would be having a bond angle of 120 degree. Okay,
Okay.
yes.
Okay.
And then what happens? It is going to combine with this HBr. And now what actually happens? A molecule is going to be formed like this. This hydrogen is going to attack here. So they here, and this hydrogen would form here, and the Br comes at this place. Okay, so we have seen that the hydrogen goes at this point, bromine goes at this point, and the double bond here would be finished. Okay,
Okay.
yes. So let's discuss about their mechanism, which is very important because it is oftenly asked in the exam. Oftenly asked in the exam. Like I have told you the importance of free radical substitution reactions in alkanes. Do you remember that?
Yes.
The same importance is for this particular question as well. That is, in the mechanism, we have to show dipoles, we have to show curly arrows, and we have to show lone pair charge. Everything has its own marks. So we have to be very careful. C double bond C, H, H, this H, and this H, plus HBr is going to react. So we know, just remember one thing, when this double bond is coming near to this place. Okay, let me just draw it in this particular manner. I'll draw it here. Plus, this is H, this is Br. Okay, now just see what I'm going to do. When this polar bond is coming near to this place, is coming near to this molecule, then what happens at this instant? There is electron repulsion. You know, this is electron repulsion. The electron here that is going to be repelled, and we know that bromine being more electronegative, it is going to pull this electron towards itself. Is it clear? So when it
Yes.
is coming near to this place, I'm going to draw this arrow. So what happens? A partial positive charge will form on this one, and a partial negative charge will form on bromine. Why? Because when we are this molecule of ethene is coming near to this HBr molecule, then you know that pi bond having greater electron density, or you can say more spread electron density, would cause the repulsion in the electron. And as bromine is more electronegative, that is trying to pull this electron towards itself. Is that clear? So a partial
Yes.
positive charge would be created on hydrogen, and a partial negative charge would be created on bromine. And now what happens? This electron would move at this point like this. Sultan, these arrows are very important. These arrows are very important. This arrow, this arrow, this arrow. They are very important. You must need to remember these things. Now,
Okay.
what happens? There will be a fission reaction that is going to take place here. So this kind of fission is basically called as, yes, we have discussed two type of fission, homolytic or heterolytic. So what kind of fission is this one?
This is um heterolytic.
Very good. So this fission is basically called as heterolytic fission. So a bond is going to break, and now what happens around here? This is carbon, this is carbon, this is hydrogen, and now this is hydrogen. And you know, this is basically electrophilic addition. This is electrophilic addition because this is electrophile that is going to be added in this one. Okay, that is going to be added in this one. So what happens? You know, these are two electrons of pi bond that is moved from this place to this place, and hydrogen is going to attach like this. Is that clear?
Yeah.
So this electron would actually move at this point, and hydrogens are this hydrogen is going to be attached at this place. Now, what happens? This is hydrogen here, this is hydrogen here, and you know its electron, the carbon electron has moved towards this point, so it is going to carry a positive charge like this. Is that clear?
Yeah.
Or you want me to explain it one more time?
No, I think it's fine.
Okay. So let me explain this thing again, that these two electron would move on this side and this electrophile is going to add at this place. Okay. So first of all, this kind of reaction, okay, wait, just one more thing. This electron has been moved towards bromine and now bromine would be like this with this two electrons. Is that clear? These two electrons are
Yeah.
this and with a negative charge on it. So now what happens? Bromine is going to attack here at this place and it is going to form the structure like this. This mechanism is very important. I hope you have learned everything in this mechanism.
Yeah.
So, bete, this question will also come that what kind of a reaction is this one? So, you are going to explain that this reaction is basically a electrophilic addition reaction. Electrophilic addition reaction. Is that clear?
Yes.
Okay, let's move further. Now, we are going to have some unsymmetrical molecule and let's see what is going to happen with them. This is CH3, this is CH, this is double bond CH2. So this is basically an example of an unsymmetrical molecule. And when HBr is going to have a reaction with them, we know it is carrying a partial negative charge, it is carrying a partial positive charge. There is a rule which is named as Markovnikov's rule. Markovnikov's rule. And what it states that hydrogen will move towards uh, that place which has more number of hydrogen. Okay. So two products we are going to form. In the first one, what is going to happen? That hydrogen, you can say the one which is having a partial positive charge, this is having a partial positive charge, you can see, and this is having a partial negative charge. So what is going to happen? Hydrogen is going to move to that place which has more hydrogen, which has more hydrogen. Is that clear? And this
Yeah.
one, which is having partial negative charge, is going to move to that place which has less hydrogen, less hydrogen. And they are going to make a major product. They are going to make a major product. This thing must need to be remembered that they are going to make a major product. And now, let's make their structure. So it is going to be CH3, CHBr, and this CH2 uh, hydrogen would be attached to it. So it is going to become CH3. Okay, it is going to become CH3. You can even say that, sir, uh, at which part we need to consider. So this is the reactive part because of having a double bond here. So this is a reactive part. Okay. So in the reactive part, what is going to happen? The hydrogen is going to move to the, uh, you can say, carbon, which is having greater hydrogen. Is that clear?
Yes.
So this is going to become CH3. Is that clear?
Yes, okay.
Okay. So now this, this is CH3, CH, double bond CH2, and now I'm going to make uh, a minor product. This is a major. Okay. So this is a major product, and now this one would be a minor product. So in minor product, the opposite thing is going to happen. Hydrogen is going to move to the one which is having less hydrogen, and bromine is going to move to the place which is having more hydrogen. So now the structure would become CH3, CH2, CH2 dash Br. Is that clear?
Yes.
Okay. Now, there is one more important thing. You can see here that, these two electrons, I have told you, like these two electrons, now they would be removed from here. So there would be a positive charge at this place. Okay. At this place. So there would be a positive charge. And now what happens? This is basically a minor product. In the exam, they are going to ask you one thing as well. Why 2-bromopropane? Why 2-bromopropane is a major product? Is a major product. So how you are going to answer that? This is 2-bromopropane, like we have, this is CH3, CH with a positive charge, this CH3, this is bromine. Now, you know that this alkyl groups, these are alkyl groups, they are basically electron donating. They are electron donating. Two alkyl groups, which are attached, are electron donating, are electron donating. So what happens? It can basically, they are electron donating so that it can make CH plus more stable. Okay. So
Okay.
they make CH plus more stable and decrease its decrease its
Reactivity.
yes, reactivity. How? By decreasing its positive charge. Because when they are as they are electron donating, they are basically donating electrons from both sides. From both sides they are donating electrons. So what happens? The positive charge in the middle would be decreased. Its positive charge density would be decreased. So that is why they are going to make it a more stable product. Is that clear? And that
Yes.
is why it is going to be a major product. Okay?
Okay.
So let's move a little bit further and let's discuss some more examples of them in detail. Now, we are going to have some identification test of alkenes, test of alkenes. Let me just discuss about them. First of all, we are going to have this bromine test. We are going to have this bromine test. Okay. So in bromine test, what is going to happen? Like, for example, this is alkene. When it is going to have a reaction with this Br2, then what happens? Bromine is going to attach here. Okay. Before, bromine was having reddish brown color, and now its color is going to be changed to colorless. Colorless. So this is basically a bromine test, which is quite important, and it is oftenly asked in the exam that what is the test for alkanes. Okay, test the presence of alkanes. Like if you have alkanes and alkenes, then we are going to have bromine test. There is no effect of bromine when we are going to place it in alkanes. But when we are going to place bromine in alkenes, its color is going to change from reddish brown color to colorless. Okay, to colorless.
Okay.
Now, it is going to have an other test, which is K-MnO4 test. So alkene oxidation can be done with KMnO4 alkenes. Oxidation can be done with KMnO4. So its color will change from purple to colorless. From purple to colorless. Is that clear? So you can
Yes.
see its color is basically changing from purple to colorless. Now let's move further and let's discuss some of the more reactions of alkenes. The first one is hydrogenation reaction, which hydrogen is basically attached to is attached to alkenes. How it is going to happen? This is hydrogen, and the catalyst is very important. A nickel catalyst that we are using. So what is going to happen? This molecule is going to change from CH2 dash CH3. Okay. So this is basically a hydrogenation reaction. And now let's move further towards hydration reaction. Towards hydration reaction. Hydration reaction is basically addition of water, or you can say it would be steam. So what is going to happen? CH3, CH, double bond CH2. And when water is going to add in it, so what is going to happen? That this reaction is going to proceed at 360 degrees Celsius. And the catalyst is going to be very important. That is phosphoric acid. That is going to be asked again and again as well. Oh, sorry. This is very important. And now what happens here? I'm going to split this water, okay, this water in H dash OH. We know it is having a partial positive charge, it is having a partial negative charge. So first of all, we know according to Markovnikov's rule that H positive is going to be at this place, and OH is going to be moved towards the hydrogen which contains towards the carbon which is having less hydrogen. So it is going to become CH3, CH. OH and then CH3. So this is basically a hydration reaction. Is that clear, Sultan?
Yes.
Okay. So let's move further and let's discuss about the last topic of alkanes, and that is oxidation in alkene. So there are basically two ways. You know what we mean by oxidation? Oxidation means addition of oxygen. Okay. So they are basically, first of all, how we are basically doing this oxidation in alkanes.
Does oxidation also mean loss of electrons?
Yes, it also means loss of electron. Even it also means loss of hydrogen as well. Okay. It also
Okay.
means increase in oxidation state as well. Okay. We are going to do this chapter later.
Okay.
So let's discuss about what we mean. First of all, oxidation in alkene has been done with acidified KMnO4. Okay. We know that its color is going to be changed from purple to colorless. Now, either it can be done by cold, dilute, acidified PMNO4, PMNO4, or the second process would be by hot, concentrated. This was dilute, this is hot. You can find the difference. Concentrated, acidified KMNO4. Is that clear?
Yeah.
Now, first of all, let's discuss about this one. What is going to be happen when it is going to react with cold dilute acidified KMNO4? Only pi bond is broken. Only pi bond is broken. And what happens? We add OH group to both carbon. To both carbon. Okay? Like for example, we have this CH3 dash CH double bond CH2 plus this is acidified KMnO4. We present it with oxygen. And then we have this water as well. So what is going to be happen? OH, you know, they are two OH. Okay. This one will make one OH and the other one is
Yeah.
other OH. So it is going to attach like this. Is that clear?
Yeah.
So this basically, what does it basically represents? It basically represents the color change is basically from purple to colorless, you know it. And this reaction is basically for when we are doing with cold dilute acidified KMnO4. Is that clear?
Yeah.
Okay, so let's move further towards the second part, and that is going to be for hot concentrated acidified KMnO4. There are basically certain rules which we must need to remember for them. That is both pi and sigma bond will break in it. In that only pi bond was broken. But in this both